Hello and welcome to a new tutorial about conifer tools. Today I'm going to talk about setting up technology file for Python MCell library. Technology file is simple YAML file in which we describe technology that is going to be used by MCell. Here I have example of open source IHP technology. First thing that we need to do is to set up grid for a given technology. Then we need to set up meta layers. As you can see here, first we set the name for the meta layers, and then we have additional attributes. For example, here, this is the metal 1. We have here name metal 1. Height is the height of the metal 1 layer, which is the distance between substrate and metal 1 layer. Actually, this reference point can be also backplate of the wafer, and that reference point is not that important. What actually is important is relative distance between metal layers. Anyhow, height has to be always positive. So natural reference point that you can choose is either this one here, which is substrate, or you can choose a backplate of the wafer. Next parameter is the thickness. So this is the thickness of metal 1 layer. Then we have minimal width for the metal layer. So metal layer cannot be drawn with the width less than this one here. Then we have minimal spacing between two metal 1 polygons. We have conductivity, and here we have a mapping of a given metal layer to GDS2 layer. So we have a number of GDS2 layer and we have type of GDS2 layer. And we do the same for all metal layers. So we have metal 1, metal 2, metal 3, metal 4, metal 5, top metal 1 and top metal 2. Then we do the same for all vias. Vias are vertical connections between adjacent metal layers. So we have top, this is a top metal layer for a given bias. This is this layer here, metal 2, and the bottom. Bottom metal layer is metal 1 in this case. Then we have width and height of the via. So vias have constant dimensions, and here we give width and height for a given via. Then we have minimal space between two adjacent vias, and we have metal enclosure for a given via. So let me maybe draw here. So via usually has constant size. This is horizontal cross section. So we have here height of the via, and we have here width of the via. Very often height and width are the same. Then if we have via, it needs to be enclosed with top and bottom metal layer. And this minimal enclosure is actually given with this number here. Then we have conductivity of the via, and again mapping to GDS layer. Next part is dummy fill. Dummy fill is a little bit more complicated. First we have box, and box is layer that is going to be used to draw the box. Dimensions of this box are not given in technology file, but they will be given independently for every single cell. Then elements. Elements are actually dummy fields. Actually, these are most of the time some kind of logical layers. For example, if you want to say, okay, in this area, do not make any kind of automatic dummy field, something like that. But a real dummy field is actually given by elements. We can see elements here. So we have first element, and it is mapped to metal 1. This means that this is going to be dummy field for metal 1. This is the starting point. Actually, starting point would be something like this. These elements, they are rectangulars, and starting point is the point here, and it is relative in respect to the lower left corner of the box. And dummy fill is going to be done in X and Y direction. So it will be something like this, and it will be in this direction as well. So this box is going to be filled out with small elements. Here we have width and height of the element. So this would be width, and this would be height of the element. Then we have dx, which is shift in x direction. So this is basically this part here. This would be dx, and we have dy, which would be this part here. Enclosure is minimal distance between element and the edge of the box. This is this part here, and that's relevant because when we do the filling, question is what is going to be the last element. So it will be able to put this element there if this distance is larger than enclosure that is given here. Later on, it can do recentering of all of these elements so that we have uniform distribution inside the box. But recentering will be done for all elements all together. So all elements can move, but they will move all together inside of a given box. And then last part is mapping to the corresponding GDS tool layer. We can see here that we have the same mapping between this dummy fill element and metal 1. Sometimes in some technologies these numbers are not the same, but still we need to know which dummy fill element is this one. It has to be associated with one of the metal layers because sometimes when we do dummy fill here, there might be some element, for example in metal 1, that already exists in the cell. And dummy fill will be done in a way that it will respect DRC rules over the present metal layer. So it will only place dummy fill element if minimal spacing is given by this number. Otherwise, dummy fill element will not be placed. For example, some dummy fill that is too close to metal 1 layer, it is supposed to be placed here, but since this distance is too small, this dummy element will not be placed.